Hello everyone, this video is a revision on the motion graphs for objects moving with constant velocity. You can now see two examples of objects moving with constant velocity. The top example shows an object moving with constant positive velocity, and the example at the bottom shows an object moving with a constant negative velocity. Now, looking at the positive velocity, we obtain velocity from the final position minus the initial position divided by the time interval. To get a positive velocity means that our final position is more than the initial position. That's how we can get a positive numerator. So a positive velocity implies that the object is therefore moving forward, and this is one of the very crucial descriptor that you need to use if you were to describe the motion in words. Conversely, a negative velocity implies that the object is moving backwards. Let's now look at the position time graphs for these two scenarios. For the first scenario at the top, with a constant positive velocity, as we have figured out, the object is moving forward with the position becoming more and more positive as time passes. This means that the position time graph is an increasing straight line. Now, there are many possibilities for this increasing straight line. The initial position can start from here, it can start from here also, it can start from, in fact, anywhere. So this series of straight increasing line shows the family of graphs for the position time graph of an object moving with constant positive velocity. If the question tells you that the object starts from the origin, then the only position time graph for the scenario will be this red line that is increasing. For the second scenario with constant negative velocity, the object is moving backwards, and therefore the position is becoming more and more negative as time passes. This implies that the family of graphs to be drawn for the position time graph will be downwards straight line as shown here. Again, if the starting position of the object is being told to you as, say, at 10 meters, then this red line will be the only graph that will describe the scenario. Now, let's try giving some values to this graph over here. Say it takes 1 second for the graph, or rather for the object, to move from 10 meters to 0 meters. This means that the speed of the object and the velocity of the object will therefore be negative 10 meters per second. This is how I would describe the motion in words. The object is moving with a constant velocity of negative 10 meters per second, moving backwards from 10 meters to the origin in 1 second. Again, it is crucial that you mention that the velocity is constant and the object is moving backwards. Now, to wrap up the motion graphs, we are left with the motion graph of acceleration against time. Knowing that these two objects move with a constant velocity, the velocity doesn't change. Therefore, with no change in velocity, your acceleration value will therefore be 0 for both scenarios. And this will conclude your revision on the constant velocity motion graphs.